My sister Julie just moved into a new house, and she asked me if I'd build her a dining table. I said sure. Then she said she wanted a 72-inch round pedestal dining table. She wants the legs to be out of the way so you don't kick them when you sit down. Oh, and she wants it to be made out of walnut. Well, I already said sure. What was I going to do? So this is the biggest thing I've ever built. I usually build things like credenzas or end tables. I've done a crib and a couple of beds, just no large tables until now. So I asked her to show me pictures of the kind of table she wants. Problem with these designs is I don't have a lathe to turn the legs. Well, I have a lathe, but I use it to do things like turn drawer pulls. I'm really not much of a turner. So I said I'd come up with some design ideas for her to look at. She felt like most of these were too modern, but she did like this one, which was cool because it was my favorite too. The design is simple. A base and a sub-base support 10 legs. Those legs attach to a mounting plate, and the table sits atop that plate. It meets the functional goals, and I feel like it's reminiscent of the turned leg pedestal tables that she likes. So that's what I'm going to build. The boards were already pretty dry, so I let them acclimate to my shop for just about a week. While I waited, I created a template for the leg shape. I don't have a CNC or a laser cutter, so I just printed out the full-size drawing. And then I taped them together using a window as a light box. Then I just took my time cutting it out as good as I could with an X-Acto knife. Found a scrap of a 1/4-inch plywood that I had around, taped the template to it, and traced out the shape. Then I rough cut it out at the bandsaw and cleaned it up with the sander. One of the things that separates a nice piece of custom furniture from the mass-produced stuff is taking your time to find the best grain alignment for the boards. I probably spent about 30 minutes doing this. I'm going to cut the top, base, and all 10 legs from these 10-foot boards that are all around 8 inches wide. So I cut out a cardboard pattern for the top and the base, and then using those along with the leg template, I laid everything out to make sure it all fits. I rough cut the boards to length and jointed and planed them to close to their final thickness. Then I stickered them and let them sit overnight before milling them to their final thickness. The base is made out of 2 panels, with the top one being 3/4 of an inch thick and the bottom being 1.5 inches. The process is almost exactly the same for these 2 parts, so here's a little split screen action. I'm using dominoes for alignment on the 8/4 and biscuits on the 4/4. There's a good deal of repetition in this build. I have to cut out a lot of circles, so I tried to skip some of the repetitive stuff and just focus on the differences. For the base, and later for the top, I use a router with a circle cutting jig and a jigsaw. Then flush trim the edges with a router. Finally sand it up through 180 grit and adding a round over to the edges. To glue the parts of the base together, I used a vacuum bag. I left the glue about 1 inch away from the edge to keep from having to clean up a bunch of squeeze out. Here you definitely want to make sure to align the grain direction of the two parts so any wood movement is in the same direction. I left it in the bag overnight. On to the legs. Just like when I made the pattern, I'm now tracing the pattern onto the blanks. Rough cut them at the bandsaw. Cut them to final length. If you were only doing a couple of legs, you could just attach the pattern to the piece with double-sided tape and use a pattern bit to flush trim the edges with a router. Since we're doing 10 of these, I decided to build a jig to make it easier and less prone to errors. I'm making the jig double-sided to account for the changing grain direction in the piece. If you route the entire edge in one go, you have to route uphill in a couple of places. Even with a really nice compression bit, you can still get a rough finish. This jig allows you to route only the downhill sections and then flip the piece over and route from the other side. Using a pattern bit, I routed the downhill section on all of the legs. Then I flipped the clamps around and routed the downhill sections on the other sides. And finally, I used a top bearing bit to route out the rest. My drawing for the legs left the points at the top and bottom a little too sharp, which left them brittle. You can see some breakage here. So I struck a line across all the legs and sanded the sharp edges down a little bit. Clamping the legs back together, I used a soft sanding pad to get them all smooth and consistent. On the outside edge of the legs, I routed a thumbnail profile using a large roundover bit. Then I cleaned them up with a little hand sanding and some planing. And finally sanded them up through 180 grit. As I mentioned, I'm using an aluminum plate to attach the legs to the top. It's a pretty simple design, a circular aluminum plate with one set of countersunk holes to attach the legs and another set of slotted holes to attach the top. You could make this yourself with a CNC or even just laying out the hole locations and drilling them, or you could work with a local machine shop or one of the online ones. I ordered mine from Xometry. It took just around 2 weeks to receive and came really well packaged. Since you're bolting the legs to a metal plate, you don't have much margin for error in the hole locations. So I created a drilling jig to ensure all the holes are in the right place. First, I ripped a scrap of plywood to the exact width of the legs. Then I drilled holes to match the aluminum plate. And finally, I cut and glued on some fences to align the jig with the back and sides of the leg. So using the drilling jig, I marked the locations of the holes into the tops of the legs. Then I used a drilling guide to ensure I drilled the holes perfectly vertically. Then I chamfered the holes and added some epoxy. And finally install the threaded inserts. Lots of threaded inserts. This is a twofer as you get circles and jigs in one piece. I used a bandsaw jig. Wait, is that another jig I didn't count? Anyway, I used a bandsaw to cut the circles this time. I call this the leg alignment jig. Pretty catchy, eh? It helps align the legs, but it also helps mark the locations of the holes I have to drill in the base. Now I attach all the legs to the aluminum plate for the first time. I attached 3 legs this way to get the whole thing stable so I could lift it up and set it on top of the leg alignment jig on the bench. Then I attached the remaining legs. Then I glued spacer blocks onto the jig to set the positions of each leg. I used wood glue for long-term hold and CA glue and activator to hold it in place while the wood glue dries. I let it sit for an hour and then lifted it off the jig. I had a moment where I thought I had accidentally glued the legs to the jig. Luckily, it came loose. Then I flipped the whole thing upside down. It's definitely getting too heavy to move. Similar to the top of the leg, the bottom will have 2 threaded inserts as well for the base to attach. We want these holes to be consistent too, so you guessed it, another jig. This one's pretty simple. It just makes the holes consistent for each leg. Using the jig, I marked the hole locations onto the leg alignment jig. Then I drilled the holes. Next, I set the leg alignment jig back onto the legs so I could mark the hole locations into them. Then I removed the legs from the plate so I could install the threaded inserts into the bottoms. That process is exactly the same as it was for the tops of the legs, so let's skip that part. I flipped the base over and attached the leg alignment jig with a dowel to align the centers and double-sided tape to keep it in place. Then I marked the hole locations into the base. And finally drilled the holes completely through the base. I drilled them oversized to allow for wood movement. Finally, I routed out a recess in the base to allow clearance for the bolts. This was by far the most time-consuming part of this entire build. I don't know if there's a better way to do this, but if you know of one, please leave a comment. I ended up using the router jig to route a circle trench first on the outside perimeter of the hole. Then I used a router on a long base that spanned the recess to nibble away at the remaining waste. Finally, I used a router flattening jig I had built for a previous project and a surfacing bit, and then a hand sander to get it as smooth as possible. This whole process took about 2 hours. Now that all the base components were built, I could assemble it completely for the first time. First, I attached the legs to the base, leaving the bolts only finger tight. Once the legs were attached to the base, I added the plate to the top of the legs. I have to say I'm really happy with how this turned out. Finally, it's time to tackle the top. I built these support beams to make it easier to deal with a top this size. They clamp down to the bench to hold everything solid since it's so heavy. So I laid the boards out the way I had planned originally. These boards remained fairly flat, so I only had to face join a couple that had a small twist. Of course, right as I get into it, the dust collector needs to be emptied. The 55-gallon drum is awesome, but it does make emptying it a little bit of a workout. I planed all the boards down to about 1.5 inches thick. Then I did the in-out method to joint the edges of the boards. These boards came S3S or surfaced 3 sides from the lumberyard, so I jointed the already jointed edge first. Then I ripped the other edge on the table saw. Finally, I jointed the just ripped edge. Once the boards were all jointed, I marked out the circle again. I'd lost about 2 inches over the width of the panel from the milling. Then I marked the location for the dominoes, making sure to keep them away from the edge of the circle. The challenge with a table this size is that once it's glued up, I can't move it by myself. So I thought I'd try something novel to see if it would work. First, I'd glue the top up in 2 halves. I started by gluing up 3 boards in each half. Once the glue was dry, I added 2 additional boards onto each half. So my brilliant plan was to use domino connectors to temporarily attach the 2 halves to each other. I wanted to see if they would be strong enough to hold the edges together while I shaped it into a circle, sanded it, did the edge profiling, etc. This would make them detachable, which meant I could move the 2 halves around and flip them over by myself. If you're not familiar with domino connectors, they're generally used to create knockdown joints so you can take pieces apart for shipping. Basically, you add half of the connector to each mating domino mortise, and then you can connect them with a set screw. The set screw creates a cam action on the attachment pin that draws the 2 parts together. So I laid out the mortise locations for alternating dominoes and connectors. Then I routed them. For the domino positions, I used small mortises on one edge and medium ones on the other, since I'm only using them for alignment. Then I inserted the dominoes with no glue and installed the connectors. One downside of these connectors is you have to drill a hole through the piece to access the tightening screw. It's on the bottom of the table so you won't see it, but still, there's a hole there. Once all the dominoes and connectors were in place, I attached the two halves of the tabletop together. Again, I'm not using any glue here, this is just a temporary attachment. As you can see, the connectors do pull the joint together, but ultimately I just didn't feel like it was tight enough or strong enough or repeatable enough to move forward with routing it into a circle and doing everything else that I needed to do. So I bailed on the idea and moved forward with a regular glue up. Working alone, you have to improvise. The two halves of the table were too heavy for me to lift alone, and I didn't have anyone around to help. What I should have done was glue the top up in 3 pieces instead of 2. Maybe next time. So I did one of the sketchier things I've done in a build. I wrestled one half of the tabletop up on edge so I could apply glue. If I added glue while it was lying flat, a lot of it would run off and it would be hard to get a good joint. This is me trying to psych myself into doing it. So I spread copious amounts of glue on the edge. Then carefully laid the half back down. In retrospect, this really was pretty stupid. I should have just waited until I could get help, but sometimes I just want to push forward. Then I clamped the whole thing together using every long clamp I could find. Then I checked to make sure it was flat. I don't have a straight edge this long, so I used a track saw guide rail. I let the glue cure for 24 hours. Then I scraped off the squeeze out and sanded to 120 grit to get everything mostly level. This is the top face of the table, so I don't want to drill a hole for my circle routing jig. Actually, my jig's not big enough to route a 72-inch circle anyway, so I put together a new one that's long enough and uses a plate that's double-sided taped to the table as a rotation point. Then, just like before, I routed a circle trench. And then finished up with a jigsaw. Then flush trimmed the edge. Added a round over. And then sanded the whole thing up through 180 grit. The complete top weighs about 140 pounds, according to ChatGPT, so I needed to enlist help from my friend Andrew to flip it over. Then I could sand the bottom and add a round over. I decided to install steel C-channel into the bottom of the table to help it stay flat and give it support. If I was installing it on a wider base with aprons, I probably wouldn't do this, but since it's going on a pedestal base, I thought it was necessary. First, I routed 2 grooves for the channel to go into. My 1/4-inch spiral bit is really dull at this point. I need to replace it. Then I marked and installed threaded inserts to hold the channel in place. Then I attached the channel, making the center screw fully tight, but leaving the others just snug to allow for wood movement. Next, I routed out another circle to act as an alignment jig for the top. My intention here was that this would be something removable and only used during assembly. Then I marked the locations for threaded inserts. Yes, more threaded inserts. And drilled the holes and installed them. These will hold the plate to the bottom of the tabletop. It was at this point I realized that the top alignment puck would really be hard to remove once the tabletop was installed. Also, it would probably get lost in the years between moving the table. So I decided to make it permanent, which meant I needed to make one out of walnut. I usually use Rubio Monocoat, but decided to try Natura One Coat this time. They're both hard wax oils, so it should be pretty similar. The first step is to remove any dust from the legs. I'm using Rubio's raw wood cleaner, but you can also use acetone. Then I mix up the one coat in a 3-to-1 ratio. I apply it to the legs using a white non-abrasive pad. Let it soak in for about 15 minutes and then wipe away whatever's left with blue shop towels. Since the base has a larger surface area, I first trowel it on with a spreader. Then I put a white non-abrasive pad on the sander and buff it in real well. Let it sit and then remove the excess again. Hard wax oils claim you only need a single coat. While I found that to be true with some wood species, with walnut you really need a second coat in my opinion. Before you can apply the second coat, you should let the first one cure for about 48 hours. Then you scuff up the first coat by using a maroon abrasive pad. After you remove all the dust, you can apply the second coat in the same way as the first. The second coat goes on much easier and you need a lot less of the oil. The bottom face at the top has a lot of things to work around, so I first applied the finish by hand to the C-channel slots and around the threaded inserts. Then I troweled on the finish and used a buffer to spread it around. I let it dry for about an hour and then flipped it over so I could apply finish to the top face. With no obstructions on the top, I could just trowel the finish on and then buff. After 48 hours, I applied a second coat in the same way as before. I let the finish cure for a week. The table's too big to fit in my truck. I could make it work for a local delivery, but it's going a few hundred miles, so instead I rented a larger one. Unfortunately, the bed isn't flat, so I needed to build a support structure to hold the tabletop. Once that was done, I wrapped the top and base in moving blankets and wrapped them in plastic wrap. Then loaded them into the truck. Andrew and I loaded the top first and then the base. And then strapped it all down. I got on the road early the next morning. Then I enlisted my nephew Isaiah to help unload everything. Polly helped too. Everything went together well. It was only the second time it had been fully assembled. If you made it to the end of the video, thank you so much for watching. This is my first full-length video and I still have a lot to learn. So please comment and let me know what you liked and what I could do better. See you next time.